Ever been at a stoplight and heard that deep, rumbling sound next to you? That unmistakable vibration that seems to echo through the air, making you turn your head and wonder what's creating that powerful noise. That's the sound of freedom, a symphony of power and possibility that only a motorcycle engine can deliver. It's more than just noise, it's a feeling, a sense of adventure waiting to be unleashed. It's the sound of a motorcycle engine just waiting to go, eager to burst into life with the twist of your wrist. Each rev is a promise of speed and excitement. These engines aren't just metal, they're the heart and soul of the machine. Every bolt, every gear, every polished surface is part of a living, breathing entity that transforms fuel into motion. Some purr, others roar, but all have unique personalities. The sound of each engine tells a story, from the gentle hum of a commuter bike to the thunderous growl of a cruiser. Understanding what's happening inside connects you to the ride on a whole new level. It's like learning the language of your machine, feeling every pulse and vibration as you ride. The basic idea? Turning small, controlled explosions into forward motion. Each spark ignites a burst of energy, pushing pistons and spinning wheels. Imagine harnessing thunder and lightning inside a metal box to send you down the road. It's a controlled chaos, tamed by engineering and precision. When you twist the throttle, you're telling the engine to breathe deeper and unleash its power. You're in command, controlling the flow of energy with just your hand. Every part, from the smallest screw to the biggest piston, works together in harmony. It's a mechanical orchestra, each component playing its part to create smooth, reliable power. No matter the engine's size or shape, they all share the same fundamental magic. Whether it's a V-twin, an inline-4, or a single cylinder, each design brings its own character and performance. Today, we're pulling back the curtain to see what makes these machines tick. We'll explore the secrets hidden beneath the metal, discovering how raw power is transformed into smooth acceleration. We'll break it down step by step, from starting the engine to hitting the road. You'll see how every movement, every spark, and every turn of the crankshaft comes together in perfect unison. By the end, you'll have a new appreciation for the engineering behind every ride. You'll understand why motorcycle engines aren't just machines. They're the beating heart of every journey, and the reason riders feel so connected to the road. At the core of most motorcycles is the four-stroke engine, a marvel of engineering that has powered generations of riders. This engine operates through four distinct movements of the piston, which together complete one full power cycle: intake, compression, power, and exhaust. Each of these strokes plays a vital role in transforming fuel into motion. First comes the intake stroke. As the piston moves downward, the intake valve opens wide, allowing a carefully measured mix of air and fuel to rush into the cylinder. This mixture is the lifeblood of the engine, setting the stage for what comes next. Next is the compression stroke. The piston rises, squeezing the air-fuel mixture into a tight space. This compression is crucial. It increases the potential energy stored in the mixture, making the upcoming ignition far more powerful. The more tightly you compress the mixture, the bigger and more forceful the bang when it ignites, resulting in greater power output. At the very top of the stroke, the spark plug fires, igniting the compressed mixture in a controlled explosion known as the power stroke. This explosion generates a tremendous force, slamming the piston downward. That force is transferred through the crankshaft, ultimately driving the wheels and propelling the motorcycle forward. Finally, the exhaust stroke begins. The piston moves up once more, the exhaust valve opens, and the burnt gases from combustion are pushed out of the cylinder, making room for a fresh charge. This entire cycle repeats itself thousands of times every minute, creating a seamless flow of power that keeps the motorcycle running smoothly. Each stroke is essential, working together in perfect harmony to deliver the smooth, powerful motion that riders crave. The timing and precision of these movements are what make modern engines so efficient and reliable, ensuring every part works in perfect sync. It's a mechanical dance, perfectly choreographed, with every component playing its part in a symphony of motion. This is the heartbeat of every ride, the rhythmic pulse you feel beneath you as you twist the throttle and take off down the road. Simple in concept, but brilliant in execution, the four-stroke engine is a testament to human ingenuity and mechanical artistry. That's the magic of the four-stroke engine, a timeless design that continues to inspire and excite riders everywhere. Before the engine can run, it needs a push to get moving. Old bikes used a kickstarter, a lever you'd kick to spin the engine. It's a hands-on, satisfying way to wake up a machine. The kickstarter turns the crankshaft, moving the piston through its first strokes. If timed right, the spark plug fires and the engine roars to life. Modern bikes make it easier with electric starters. Press a button, and a starter motor spins the engine for you. The starter motor meshes with the crankshaft, doing the same job as your leg. Once the engine fires, the starter disengages. No more sweaty mornings, just thumb the button and go. It's a simple, reliable system. Whether by kick or button, it's all about getting that first cycle started. And then, the real fun begins. After compressing the air and fuel, it's time to ignite. The spark plug creates a spark at the perfect moment to fire the mixture. Timing is everything. Too early or too late, and the engine loses power. The ignition coil boosts battery voltage to thousands of volts for a strong spark. On modern bikes, the engine control unit, ECU, controls when the spark fires. The ECU knows the piston's position and fires the spark just before the top of the compression stroke. This is called ignition advance, ensuring peak pressure as the piston moves down. Timing changes with engine speed and load for maximum efficiency. At high RPMs, the spark fires even earlier. The ECU constantly adjusts, keeping the engine smooth and powerful. Without perfect timing, you just have a fancy air pump. The spark plug's tiny lightning bolt is the key to every explosion. That's the secret to a strong, efficient engine. The piston's up and down motion needs to become spinning motion to move the bike. The crankshaft, connected by a rod to the piston, converts this motion into rotation. Each power stroke spins the crankshaft, building momentum. The spinning crankshaft sends power to the gearbox or transmission. The transmission uses gears to control how power reaches the rear wheel. From there, a chain and sprockets, a shaft, or a belt drive transfer power to the wheel. The result? The rear wheel turns and you move forward. Every part works together to turn explosions into motion. It's a seamless transfer of energy from engine to road. That's how a motorcycle comes alive. Simple, effective, and thrilling. The gearbox is a crucial part of your motorcycle. It lets you manage the engine's power and decide how that power reaches the wheels. Without it, you wouldn't be able to accelerate smoothly or handle different riding conditions. Most motorcycles use a manual transmission, which means you control both the gears and the clutch. This gives you a direct connection to the bike and a more involved riding experience. The clutch disconnects the engine from the transmission, letting you shift gears smoothly without damaging the components. It's a skill that takes some practice but becomes second nature over time. To shift, you pull the clutch lever, select a gear with your foot, and then release the clutch to engage the new gear. This process gives you full control over how the bike responds. First gear provides the torque you need to get moving from a stop, while higher gears trade some of that torque for more speed as you accelerate. With enough practice, shifting becomes second nature, allowing you to focus on the road and enjoy the ride. But not all bikes are manual. Automatic transmissions are common on scooters and some touring motorcycles, making riding easier for beginners and city commuters. The most popular automatic is the continuously variable transmission, or CVT, which is especially common on scooters. A CVT uses pulleys and a belt to provide seamless acceleration. There's no need to shift gears manually, so you can just twist the throttle and go. Some motorcycles use advanced dual clutch transmissions, or DCTs, which offer fast, automatic gear changes and can even be operated in manual mode for more control. Whether you ride a manual or an automatic, the goal is the same. Keep the engine in its power sweet spot for the best performance and efficiency. Manual transmissions give you more control and a hands-on feel, while automatics offer convenience and ease, especially in stop-and-go traffic. Both types of transmissions deliver the thrill of the ride, letting you enjoy the freedom and excitement of motorcycling. The right transmission for you depends on your riding style, experience, and where you plan to ride most often. No matter which you choose, you're in for an adventure every time you get on your bike. Engines need the perfect mix of fuel and air to run. Carburetors once ruled, using air pressure to draw fuel into the engine. Twist the throttle, and you open a valve, letting in more air and fuel. Carburetors are simple and tunable, but sensitive to weather and altitude. Today, fuel injection is the standard. Fuel injectors spray a precise mist of fuel, controlled by the ECU. The ECU uses sensors to measure air, temperature, engine speed, and more. It constantly adjusts the fuel-air mix for perfect combustion. Fuel-injected bikes start easier, run smoother, and pollute less. The result? More power, better mileage, and lower emissions. Whether carbureted or injected, it's all about the perfect mix. That's what keeps the engine running strong. Engines generate intense heat. Cooling is essential. Air-cooled engines use metal fins to dissipate heat as you ride. High-performance bikes use liquid cooling. Coolant circulates through the engine, absorbs heat, and releases it in a radiator. After combustion, burnt gases need to exit fast. The exhaust system channels gases away and quiets the noise. Pipe design affects engine breathing and power, a science called exhaust scavenging. Mufflers break up sound waves, making the ride bearable. Modern exhausts include catalytic converters to reduce pollution. These devices turn harmful gases into safer emissions. Cooling and exhaust systems work together to keep the engine healthy. Without them, performance and reliability suffer. It's all about managing heat and waste. That's how engines stay cool and clean. Engine oil is the lifeblood of your motorcycle. It lubricates moving parts, reducing friction and wear. Oil forms a thin film, letting metal parts glide smoothly. It also helps cool the engine, carrying heat away from hard-to-reach spots. Some bikes even have oil coolers for extra protection. Oil picks up dirt and metal particles, keeping the engine clean. The oil filter traps contaminants, but oil must be changed regularly. Fresh oil means a longer-lasting, healthier engine. It's the cheapest insurance you can buy for your bike. Treat your engine to clean oil, and it'll reward you with miles of adventure.